Welcome to Section 3, Query Optimization and Tuning. And just like in the first two sections, we'll initially do our installs and imports. And again, will start this sub-process that kicks off our historical database. And remember, our historical database holds two tables, a quote table and a trade table. So if you run this block here, you'll see that the partitions are created in our historical database for both trades and quotes. You can then set the database path and check to make sure that your trade and quote tables are indeed available within our database. So now we have our setup complete and we can begin section 3. In this section, what we'll be doing is completing some experiments to understand what is the best way to structure our queries to get the best possible performance. And we'll do that by trying out different parameter ordering configurations and identify which configurations and which orders will get us the best results. The first thing you'll do is get the date that's 3 days prior to today, or the day that you're taking this course. And we'll use that as a part of our query. What I want you to do is run these cells as we walk through it, and I'm going to explain how each cell works. And then we'll discuss at the end to understand which is the best configuration or parameter order and why is that. So the first experiment we'll run is a simple SQL-like select statement. And we'll be selecting data within our trade table and filtering using a where clause on symbol. So we want our symbol to be Apple and our date to be that date that we just specified above. And if we do this select statement in this order, we see it takes about 11 milliseconds to run. Now, if we do a quick switch between the date and the symbol parameters within our where clause, we see that there's a significant speed up, taking less than 2 milliseconds. So that's pretty interesting, and let's do a few more experiments to explore that concept a little bit further. Let's find the average volume for a date, time range, and a symbol. So we'll take, again, our trade table and select some data in it. We want to find the average of the volume, or the size column, where symbol is Apple, our date is the date we specified above, and our time is after 12 o'clock. Now, if we filter this order, symbol, date, and time, it takes about 7.5 milliseconds to run this query. And what if we switch the order up a little bit? Let's do symbol, time, then date, and it's still taking 7.5 plus milliseconds to complete. So we don't see really any improvement with these two orders, and let's try some more orders to see what happens. Now let's go ahead and do time, symbol, then date, and we see we're still in that 7.5 ballpark, so no improvement yet. What about time, date, then symbol? 8, it's even getting worse. Okay, so what if we put date first? Date, symbol, then time. And here we start to see a significant improvement in the speed of our query, under 2 milliseconds. And if we try one more configuration, date, time, then symbol, well, again, we're in that 1.8 ballpark. So we are dropping from 7.5 to 8 milliseconds down to 1.8. So seeing quite a significant improvement in our query speed. And why does that happen? Well, if we are filtering on date first, this makes an awful lot of sense when we're dealing with a database that is partitioned on the date column. That means our partitions are split based on date. Each partition is a single date. What that means as far as our where clause and our filtering goes is if we filter on date first, that means we are identifying the correct partition first, and the rest of the search can happen strictly within that partition. So that really speeds up how long it takes to complete the select statement. Another great way to optimize our query performance is to apply attributes to our tables. Now, attributes are just metadata that you attach to your vectors or your columns within your table that help speed up retrieval and execution during queries upon these columns. Now there's a few different available attributes within PyKX. First, the sorted attribute, which just ensures that all items within a column are in a sorted order, and that can really improve the speed of searching over that column. Unique ensures that all of the items in that column are unique values. Group creates a backing dictionary that stores the value and indexes of each item within your column. And parted, which is similar to grouped, but it has an additional requirement that each unique value must be adjacent to its copies. So these are the available attributes within PyKX, and if we apply them to our tables, we will see quite a significant speed up in query execution. Now let's think about that a little bit further, and a great example is searching across a column of data. If you wanted to search data without it being sorted, that means you would need to search each item within that column, and that could take a long time, especially if there's many items within that column. But if you apply the sorted attribute to this column and sort all the values in it, that means you can use an algorithm like binary search to significantly speed up the time it takes to search that column. So let's try this out in practice. And the first thing we'll do is load our table into memory, selecting the trade table. We'll call it memory trade table. And now let's try a query on that table where we select items in the trade table that match a date and a symbol apple. And we see it goes pretty quick, 656 microseconds. But now let's load this table and apply the grouped attribute to it on date. So if we then run the similar query, we do see quite a speed up, dropping down to 399 microseconds. Okay, so just applying that grouped attribute and using the same query, we do see a significant speed up. Let's take another example. So again, we'll load our table into memory, and let's select all of the rows that have the IBM ticker. Now, if we can apply the grouped attribute to the symbol column and then select the IBM ticker symbol one more time, is there a speed up by applying that grouped attribute here? And yeah, so we see it drop from almost 900 microseconds down to just over 600 microseconds. Let's take a look at the sorted attribute. And what we will do here is create a 10 million element vector. So this vector is quite long, has a ton of elements in it. And we want to find how long does it take to find the maximum element in this vector. So we say a.max, we'll time it, 2.91 milliseconds, okay? But now let's apply the sorted attribute to that vector. And now find the maximum again and see, do we see any sort of speed up by applying that sorted attribute here? And yes, indeed, we do see a very significant speed up here. So if you apply attributes to your column and use the most performant parameter ordering in your where clauses, you will see large improvements in your query execution speed. All right, see you in section 4.